Great. We've seen the different modules, that is categories of security vulnerabilities, the data custom findings, the posture findings, the recon findings, the runtime incidents. Let's start talking about how you can go about and analyze them and understand them and so on. These are general guidelines. These are best practices compiled by myself after having a discussion with our API security researchers. Okay, I mean no name security. Generally speaking, you want to start with highest priority, the most recent security vulnerability, the finding, the incident, and so on. Okay. Potentially, the ones that are easy to prove are also could also provide you with that quick win, right? So that, for example, well-known industry exploits like Log4j, you can easily and quickly remediate them and have them closed. Okay. I'm not saying for a second that you will be able to do that all by yourself. I'm saying that these are the easiest to work with. Okay. At the end of the day, I don't care whether you're dealing with a finding, whether you're dealing with an incident, you will need to talk to some kind of a resource. If it's a finding like a posture finding, an environment based, you're going to have to talk to the corresponding system administrator. If it's an incident, probably you need to talk to a developer resource, right? The owners of that API. Okay. Um, Data custom. These are definitely have the least amount of false positives. You define them. An API request breaks them. You need to talk to the corresponding resources, developers primarily, to fix them. Okay. Posture recon. These are proactive. Uh, I'm focusing on this. That is the fact that they're proactive because you get a finding, you may be in problem in the future. You're not in problem. You're not in trouble yet. You may be in trouble in the future. You're not in trouble yet. Okay. On the other hand, if you're dealing with data custom and runtime, these are both reactive. You're in trouble now, right? And like I said before, one of my colleagues mentioned that findings indicate posture recon findings indicate that you will be in fire in the future. Um, Incidents, you're on fire now. So if everything is the same between um, posture recon and runtime, I will definitely work on the runtime first. Okay, if I was a security professional, that is. Runtime, these are behavioral. We learn the behavior over time. We detect abnormal, anomalous behavior. And as always, because machine learning is employed and it's non-deterministic, false positives are possible. Okay. It definitely requires a group effort to analyze, not just fix, analyze, right? And we should take an attacker space centric debugging view, right? Or analyzing view of incidents, because an attacker is just a user that use an API abnormally, and you would like to have the attacker-centric view before you start working on a single incident. In fact, for the past like 6-7 months now, we've been moving slowly but surely into an attacker-centric, um, I don't know, debugging, analyzing, comprehending workflow. Some people think that you probably would like to block first, then gain access to the developer resources and debug, right? That's definitely that may be definitely one of the solutions or intermediate solutions, primarily because the developer resources are not readily available, right? You cannot go ahead and say, hey, developer, come and help me out, right? Chances are he's doing something else, okay? But you got to be careful. If you block an API, if you block a user to an API and that user is pretty much managing your revenue making, I don't know, API, you're in trouble, right? So I don't know, maybe a ticketing system, an airline's ticketing system, right? You're going to block that particular user, you cannot provision tickets, your revenue goes down, so that's more damage than good. Okay, so be careful. Uh, Yeah, block first, then debug, but always be careful. Use caution. Always be aware of penetration testing, right? We know penetration takes place all the time or often enough. Uh, take a look at the user agent. If you keep seeing the same user agent across all kind of different incidents, chances are chances are maybe penetration testing is taking place. And again, the user agent should have telltale signs whether this is from a, I don't know, penetration testing tool and so on. Okay. Um, and always validate, right? Somebody should know that penetration testing is going on, right? Validate, and if it's indeed penetration testing, use one of the allow list policies, okay? And again, the allow list policies, they're under your settings, policies, allow list. So you can go to an allow list and do it proactively. If you know that penetration testing is coming, get in here, add either the IP or seeder block, a user or a user agent, click add, and right now all incidents generated by that particular user, that IP, that user agent will not be polluting your no-name platform. Okay, reduce your workload, in other words. If it's reactive, that means penetration testing is discovered after the fact. You can go to the security, you can pick one of these. I don't know, I'm going to go under runtimes, incidents, and go and reject and add the IP user or user agent after the fact. Okay, and all future incidents will never bother you. Okay, alrighty, let's go back to the slides. What did I say, sir? Yeah, sure. Yeah, let's go back to slides. Okay, so always check for suspicious user agent and IPs. The attacker page will have the reputation of a particular IP, so always check it and verify whether this is an actual true positive or a false positive, and I'm referring specifically to incidents. Okay, verify the different number of incidents that are triggered by the same user. Right, if you see tons of incidents, the chances that this is an actual attack is higher as compared to a user that only has one. Okay. The other thing you may want to do is check the risk score as well, right? So there is a risk score for an attacker, so that will be important as well. Broken object level authorization, broken function level authorization type of incidents, they're usually programmatic bugs if they're true positives, so you will definitely require a developer. And some of the common remediation access, well, block the IP or users. Uh, if you really know that this is a true positive, use allow list policies to reduce the noise. Um, talk to the corresponding system administrators, the enterprise owners, enterprise application owners, if you see environment-based findings. You can definitely mark incidents as false positives when you know there's such, and help the model learn so you don't get bothered in the future. And finally, fix the code, right? At the end of the day, we're dealing with APIs, a product that is fairly esoteric to developers. An API is built by developers for developers. So at some point, somebody has to fix the code, right? So how are you going to go about analyzing and investigating? Well, always check what happened, right? And again, this is a word of warning. Every finding and incident is usually different. Understanding requires context and tech know-how. So you will see when we start debugging the next section, all the different pieces of information that you require to be at least aware of before you're able to understand and debug, right? And I'm telling you right now, you're not going to be able to know everything from the get-go. The more you work with a no-name platform and incidents, the more understanding you're going to gain, okay? And the easier it's going to be for you. Then what happened, very important, right? It contains exact details why this particular incident or finding was raised, and you should always read it. Okay. Then what happened will the remediation will give you the general details on how to fix this particular vulnerability. The very first one being always check the evidence and verify that this incident or finding is actually important or needs to get fixed ASAP, and so on. The attacker details, very important. Check the attacker, whether he has additional incidents. Look at the timeline. That is it a manual type of an attack? Is it an automated attack? And so on. The different incidents an attacker has will let you know whether this is an automated attack or a manual attack. Okay? Check the timeline. That's the only thing you need to check. Of course, check the evidence, right? As I mentioned earlier on. Inspect, analyze the evidence. Make sure if you obfuscate your data, well, you're going to have problem debugging, right? Because you don't see the actual data. The request, the response, path, headers, body. The response, is it successful? What do the headers look like, especially the course related ones there, especially for those of us who do not understand well course. We may have a problem, right? And of course, check the response body as well. Okay. Something else that I personally find useful is check the API changes over time. There's a changes page under inventory that gives us an evolution over time of our API, all the changes that take place. So if all of a sudden I see incidents being triggered by one of my APIs, chances are I will go and check the changes to verify whether there have been any recent modifications to the API. Okay. So that's always useful. And with this, we concluded this section as well. The next one is all about the exercises. So I'll see you in the next.